that's going to be on video for determining empirical formula of a compound from its percent. And this particular problem says, oops, I don't know how that got on there. Determine the empirical formula of the compound that is composed of 36.5% sodium, 25.4% sulfur, and 38.1% oxygen. So they gave us percents. They want us to determine the empirical formula. It behooves you, it really is an important habit to get into, is to really study the question the way that they're asking it. Find the question word, in this case it's determine. Okay, that's what they want you to do. What are they asking you to determine? They're asking you to determine the empirical formula. And then what did they give us? They gave us percents. So let's write, we have sodium, and we have sulfur, and we have oxygen. And then we're going to write the percents down. 36.5%. We have 25.4%. And we have 38.1%. Okay, let's go through the steps. Step 1. Get rid of the percents and change them to grams. And when we do that, we're assuming that we have 100 grams of the substance because we had 100%. Step 2, we're going to take the grams that we are given, 36.5 grams, we're going to change them to moles by dividing by the atomic mass or the molar mass from the periodic table. So when we look up sodium on the periodic table, we see that rounded to the nearest tenth, sodium's atomic mass or molar mass is 23 grams per mole. And sulfur, we're going to do the same thing, 25.4 grams divided by whatever sulfur's molar mass is, which happens to be 32.0 grams. And finally we get 38.1 grams divided by oxygen's molar mass, which is 16 grams per mole. Okay, we're getting a little bit faster with this. Now what we're going to do is we're going to plug them into our calculators, and we're going to get the value. 36.5 divided by 23 gives us 1.59 moles. 25.4 divided by 32 is going to give us 0.79 moles. And then finally, 38.1 divided by 16 gives us 2.38 moles. Okay, this again is our molar ratio. It's the ratio of moles in my compound. So I know that I have sodium with 1.59 as its subscript. We have sulfur with 0.79 as its subscript, and oxygen with 2.38 as its subscript. Now that doesn't work for us because we're looking for an empirical formula, and the definition of empirical formula is lowest whole number ratio. These numbers right here are not whole numbers. They are fractions, okay, or decimals. So we have to take these numbers, and for step 3, we're going to divide by the smallest number there. And I need a pen that will actually write, so let's do 1.59, 0.79, 2.38. The smallest number that we have here is 0.79. So every single one of these is going to be divided by 0.79. And we're going to get, well, we know this one's nice and easy. 1.59 divided by 0.79, and it looks like a 2. Okay, you can plug it into your calculators. 1.59 goes in first, then you hit the divide button, 0.79, and you're going to get 2. And then we have 2.38 divided by 0.79, and that looks like a 3 to me. So check it on the calculator and see if I'm right. We've got 2, 1, 3. So this ratio is going to be 2 to 1 to 3. And then we're going to rewrite it. I have to do it down here so that you can see. We've got sodium with a 2 as its subscript. We've got sulfur with a 1 as its subscript, and I'm not going to write that in because 1s are understood. Oxygen with a 3 as its subscript. and so we get Na2SO3. Now, if we want to take this one step further than this question is even asking us for, let's name this thing. We've got Na, which is sodium, and we got SO3. Now, SO3 is not one of the 7 polyatomic ions that I told you is going to be showing up very often, but SO3 is a polyatomic ion, and it is on your polyatomic ion chart. So if you take out your reference tables and you scroll to your polyatomic ion chart, right over here you see SO3, and its name is sulfite. So we can go back to, that's not the page I want, we can go back to our page, and instead of writing sulfur and oxygen, we write sodium sulfite. I need a pen. S-U-L-F-I-T-E. There you go, sodium sulfite. Okay, you could check and see if it needs a Roman numeral in here, and the way we check to see if it needs a Roman numeral is to see if sodium has more than one oxidation number. You can look at your periodic table, and sodium happens to be an alkali metal. Alkali metals only have one oxidation number, so it does not need a Roman numeral for sodium sulfite. Okay, just a quick little review.